Hello and welcome to the Godot PBR Mastery Series. In this episode, we'll be learning about channel packing. Channel packing is an optimization method where multiple textures are packed into a single texture map. This results in fewer texture samples. Texture sampling is the process of the shader fetching a texture using UV coordinates. Texture sampling is one of the more expensive operations in a shader, so reducing texture sampling can greatly improve shader performance. Channel packing can be done in most photo editing and texture creation tools. I'll be using Substance Designer as it's the most common texture creation tool and has easy channel packing functionalities. PBR materials usually contain albedo, normal, roughness, ambient occlusion, and metallic or height maps. Images usually contain red, green, and blue color channels, and optionally alpha channel used for transparency. Any of these channels can store any grayscale texture. Roughness, ambient occlusion, metallic, and height are grayscale textures, meaning they can fit into a single color channel. Albedo textures need the RGB channels to store color, but the alpha channel isn't being used, so we can store the roughness texture in the alpha channel. We can use the alpha merge node for this. Normal maps store surface direction data in RGB channels. The RGB channels store the X, Y, and Z components of the normal vector. Since the alpha channel isn't being used here, we can store the height texture in it. The Z component of the normal map can be reconstructed in the shader, so we only need to store the X and Y components. This is how most engines handle normal maps. This frees up another channel where we can store the ambient occlusion texture in. We'll need to use the RGBA split and RGBA merge node. Connect the red and green channels of the normal map to the red and green channels. Connect the ambient occlusion map to blue and height map to alpha. When packing height maps, try to store it in the alpha channel for best results. Now we have albedo and roughness in the same texture, and normal map, ambient occlusion, and height in the same texture. This results in only 2 texture maps instead of 5. If most materials in a scene use channel-packed textures, the performance gain can be significant. Let's rewrite our base material shader to use the channel-packed textures. We only need to sample each texture once and assign the channels to the variables. To reconstruct the Z component of the normal map, we'll use a derive Z function. This function uses the X and Y components of the normal map to reconstruct the Z component. We just need to pass in the normal map's red and green channel to the function.